Okay, so we're still on lesson 7.3, and this is just the second part. It says the three circle diagrams that you created for problem 3 have been reproduced in the following problems. Parts. One inscribed angle has been bolded in each triangle. A diameter of the circle has also been added to each diagram as an auxiliary line. Auxiliary just means an extra line segment. As well as some additional line segments that will assist you in writing proofs about the inscribed angles. In each diagram, prove your conjecture about the measure of an inscribed angle for the inscribed angle shown in bold. Okay, so we're going to start off with this one. And whenever they give you a point kind of like this, we always label it as a center. And so one of the first things that I see here is that it said to look for in isosceles triangles, and I found a couple. So this isosceles triangle here, this pink guy right here is an isosceles triangle, right? But also this yellow guy right here is also an isosceles triangle. Isosceles just means that these two sides are congruent, and then these two sides are congruent. So I know those are congruent because those are all radii of the circle. I'm just going to remind you of what we just learned in the previous video, which is a central angle and its intercepted arc they have the same measure. I'm going to write that down because I want you to keep remembering that. So the measure of a central angle is equal to the measure of its intercepted arc. So basically this angle in here, x, is the same as this arc measure here, x. Okay, so those two are exactly the same. Okay, now how are we going to, they want us to now prove our conjecture. And if you remember from earlier, our conjecture was the measure of an inscribed angle right here, and the measure of the inscribed angle is equal to half of the measure of the intercepted arc. Okay, half of the measure of the intercepted arc. Oops. I never put the C on this guy. Okay. So the first thing that I noticed when I'm looking at this, and this triangle kind of looks, there's like a lot of stuff going on, is that I remember from our isosceles triangles that if we have an isosceles triangle, the base angles, meaning the two angles across from or opposite of your congruent sides, are congruent. So that angle is congruent to that angle, and this angle is congruent to this angle. Okay. And the other thing that I remember is that the exterior angle theorem, and I'm just going to write this down. Let me just write down a couple things that we use. So we use the isosceles triangle theorem, which says the base angles, the base angles in an isosceles triangle are congruent. We're going to use that idea, but then we also are going to use the exterior angle theorem. It's the exterior angle, triangle theorem, which says the exterior, so the measure of the exterior angle is equal to the sum of the two remote interior angles, equal to the sum of the two remote interior angles. Okay, so what does that mean? It means in this case, right, it means that x, this angle here, is equal to, I'm just going to call this angle 1 and angle 2, is equal to the measure of angle 1 plus the measure of angle 2, right? But in this case, measure angle 1 and angle 2 are congruent. So, right, so angle 1 is congruent to angle 2. So that means that I could take this guy and substitute him in for each other. So in reality, I could write x is equal to the measure of angle 1 plus the measure of angle 1. So instead of writing angle 2 here, I substituted it into there. Because remember, hey, instead of bacon, can I please have avocado instead? And so that's what I did. I just used substitution. Well, I know that measure of angle 1 plus measure of angle 1 is the same. So an orange plus an orange is 2 oranges. A measure of angle 1 plus a measure of angle 1 is just 2 measures of angle 1, which is x. Which, if you remember from our earlier learning, we said that the measure of the inscribed angle is equal to half the measure of the intercepted arc. And here we have the inscribed angle. Here's your inscribed angle here. So this is our inscribed angle. And here we have the intercepted arc. So remember that x is equal to the arc and its central angle, right? So this is the intercepted arc. And we still have that relationship. So some of you are like, but Miss Johnson, it's twice it. Yeah, you can divide by 2. Absolutely. So we'll divide by 2 here, divide by 2. So half of the arc is the inscribed angle, which that's exactly what it says, right? So we get x over 2. Actually, I'll write it as half x. Half x equals to the measure of angle 1. So again, we got this idea that the inscribed angle is equal to half of the intercepted arc. So there we go again. We have that same idea. Okay. So here's your next one. It says the diameter lies in the interior of the inscribed angles. Hint, can you see 4A in 4B? Do you see what we just did there? Right? So go ahead and think about how you would prove. Again, we're only proving the same thing. We're proving this thing over and over again, right? But we're using different pictures of it. So do you see this picture? Go ahead and take a look at it. So for this one, when we're doing this, it said give you a hint, and it was said, do you see 4A and 4B? So what they're asking you is, do you see that central angle? And I actually see a couple of central angles. I see this one here. I see this one here. And then I also see this one here as it pertains to our inscribed angle here, right? So let's erase that green one. For the green one, if we erase the green one and we look at the pink and the yellow, we could basically cut that up into 2 parts, the pink and the yellow part. And this is exactly what we just did, except for now it's not 1, it's 2 of them. So here you can see that this would be x degrees, and this arc right here would be x degrees. And maybe this would be y degrees, and this would be y degrees. Right? And you can see how you still have these 2 angles here being congruent. And we have these 2 angles congruent, right? So you still have it. So I'm going to write a couple of equations and see if this makes sense. I'm going to label these angles as angle 1, 2, 3, and 4. So you can still see that x is equal to measure of angle 3 plus measure of angle 4. And you can see that y is equal to measure of angle 1 plus measure of angle 2. Right? And then here you could see that measure of, angle 3 is congruent to angle 4. So therefore, x is equal to it's 2 measure of angle 3, right? And then similarly, y would be the same. Angle 1 is congruent to angle 2. Therefore, y is equal to 2 measure of angle 1s. And now we're just going to add them together. Oops, I should have kept this as 2 because I want this angle back here. Okay, and then so now you can tell that x plus y, if I added these equations together, equals to 2 measure of angle 2s plus 2 measure of angle 3s, which you still get the same thing, right? If you divide out by 2 here, and take half of this, you still get, remember, this guy here is this is the intercepted arc, half of the intercepted arc, and over here we have our inscribed angles. So that's just another way to prove it. Okay, and then you could also prove it using here, this one, but again, this would be exactly the same. Okay, so I'm going to move on. It says experiment with cyclical quadrilaterals by selecting any 4 points on the circle as vertices of your quadrilateral. Use a protractor to find the measures of the angles. And then, so here what we're doing is we're still doing the same thing, and we're just looking for ways to kind of prove it. Prove that the half the intercepted arc is the measure of the inscribed angle. So I'm going to write that down really clearly here. So today we learned that half the measure of the intercepted, oops, I don't know how to spell intercepted, hold on, is equal to the measure of the inscribed angle. Okay, this was a big deal. Make sure this goes in your notes, in your brain, whatever the case might be. Okay, so that way you can practice it. So now you're able to finish your all of the things that you need to finish, homework included. Thanks for listening. Have a great day.